So dear students, how are you? I hope that you are all preparing well for your examinations, JEE Mains 2022. So hardly a very few days are there. So previously in 3 videos I explained the solutions of the problems from the chapter permutations and combinations. Okay, now I am going to explain few more problems from the very important chapter probability. So if you are very perfect in the concepts of permutations and combinations, the problems from this probability will appear to be very easy. So let us see some few problems from the chapter probability which were asked in previous JEE mains examination. So let us start our class. So dear students, welcome to our class. Now today's problem is, please read the problem and understand the problem. When a missile is fired from a ship, the probability that is intercepted is 1/3. Intercepted means some failed. It is the missile that missile is failed is 1/3, and the probability that the missile hits the target given that it is not intercepted is 3/4. Given that when the missile is not failed, then it hits the target is how much? 3/4. If 3 missiles are fired independently from the ship, then the probability that all 3 hit the target is. Try to understand this problem, very easy problem. It was asked in 2021 JEE mains. 2021 JEE mains for 4 marks. First see the solution. Okay. When a missile is fired from the ship, the probability that is intercepted is 1/3. That means what? Probability of missile intercepted is equal to how much? 1/3. That means if 3 missiles are fired, then 1 will be failed. Then what is the probability of missile not intercepted? Not intercepted, as we know that probability, this is a complementary event. So it's missile is intercepted and not intercepted, they are both are complementary events, that we know that is 1 minus 1/3, that is 2/3. What is the probability of missile not intercept? That means success, 2/3. Okay, now that then when it is not intercepted, then the probability of that missile hits the target is equal to how much? 3/4. The probability of this missile hits the target is 3/4. Understand? Now the such type of missiles are, how many are fired? How many are fired? 3 missiles are fired. 3 missiles are fired independently. Understand? So therefore, what is the probability of hitting the target? Hitting the target, that is equal to, for first missile, when it is successful is 2/3 into 2/3 into when it hits the target is how much? 3/4. This is a 3/4. This is for first missile. This is a success, that it is launched and it hits the target. Hits the target is how much? 3/4 for one missile. Such type of missiles are, how many are fired from the ship? 3 missiles are fired. That means this is for first missile, and for second missile 2/3 into 3/4, and it is third missile 2/3 into 3/4. So why you are multiplying here? All 3 are independent events. So firing the missiles from the ship are independent events. Why? Because if it is not one target hitting the target, it does not depend on first missile or second missile or third missile. Any missile will hit the target. So all three are independent events. That's why we have multiplication. Okay now. So if you see that here 3 will cancel, 2 1s are 2 2s are. This is 1 by 2. This is also 1 by 2. This is also 1 by 2. That is equal to 1 by 8. Understand? Therefore, what is the probability of hitting the missile to the target is equal to how much? 1 by 8. So the solution is very easy, and your option A is the right answer. Okay. So I hope that you understand this solution. So let us go for next problem. So dear students, welcome to our second problem. So first I will read the problem. Please see. In a group of 400 people, 160 are smokers and non-vegetarians, 100 are smokers and vegetarians, and the remaining 140 are non-smokers and vegetarians. Okay now? Right. Their chances of getting a particular chest disorder are 35%, 20% and 10% respectively. Okay. A person is chosen from the group that at random and is found to be a chest disorder. He has some chest disorder. The probability that the selected person is a smoker and non-vegetarian is a smoker and a non-vegetarian. Please try to understand the problem. So altogether in a locality 400 peoples are there. How many peoples are there? 400 peoples. In that 400 peoples, 160 are smokers and non-vegetarians, 100 are smokers and vegetarians, and the remaining 140 are pure non-smokers and vegetarians. They are very good people, right? So definitely they will get a chance of getting some chest disorders they will get. Why? Because they are smokers, non-vegetarians, like that. In the first category of peoples, that means what is the first category? Smokers and non-vegetarians. Smokers and non-vegetarians, their chances of getting chest disorder is 35%. And the second category of peoples, what are the second category? Smokers and vegetarians. Smokers and vegetarians, their chances of getting chest disorder, any cancer like that is 20%, and the remaining 140, so they are non-smokers and vegetarians, even then they will get some chest disorder, that is 10%. Okay now, right. Now in that group, one person is selected. In that 400 persons, one person is selected and he has a chest disorder, surely. Why? Because all will have some or other, they have some chest disorder. First, from that 400%, one person is selected and that selected person has a chest disorder. Then we have to find the probability that the selected person is a smoker and a non-vegetarian. He is a smoker and a non-vegetarian. Okay. So this is a conditional. This problem comes under conditional probability. To solve this problem, we should know one basic idea, that is Bayes' theorem. Okay now. So the Bayes' theorem states that, so if A1, A2, A3, so on, An be n mutually exclusive and exhaustive events of a sample space. In the sample space, there are n mutually exclusive and exhaustive events are there. And A is an event which occurs together with either of these A1, A2, A3, so on, An. So A is, that means what? In the small sample space, I am writing this here. So this is a sample space, yes. This is A1 and this is A2 and this is A3 and so on. This is An. Okay, this is An. So n mutually exclusive and exhaustive events are there. Your A is this. It will happen together. Your A is that. That means it happened along with A1 and A2 and A3, so on, An. Okay, now, right. Then, together with either of AA, that means form a partition of the sample space, yes, and A be any event, then the probability of happening of A after the happening of AK. AK means K means 1, 2, 3, so on up to N. That is K is less than or equal to N. That means the probability of happening of A after the happening of AK is given by the probability of happening of A, probability of happening of AK into probability of conditional probability, that is probability of happening of AK after the happening of A, is divided by probability of A1 into probability of A given A1 plus probability of A2 times probability of A given A2, so on up to N probability. That is sum of the probabilities this is. Okay now. So, if you know this Bayes theorem, the solution of this problem is a very easy one. Okay now. So, let us go for the solution of the main problem. So, dear students, coming to the solution of our main problem, that is second problem. So, here given total number of persons are how many? 400 persons in that locality. So, in this, so smokers and non-vegetarians are how many? Smokers and non-vegetarians are 160 and their chance of getting chest disorder is 35%. Okay. Smokers and non-vegetarian, they are 160 members and there is a chance of 35% chance of getting chest disorder is 35%. Okay. Next one, smokers and vegetarians. Smokers and only vegetarians. They smoke but they are vegetarians. They are 100 in number and their chance of getting chest disorder is 20%. Okay, 20%. And the third persons are very good persons. They are non-smokers and vegetarians. Their number is 140. Their chance of getting the probable chance of getting the chest disorder is 10%. So, the problem is very clear. So, smokers and non-vegetarians are 160 members and their chance of getting a chest disorder is 35%. Okay. Smokers and vegetarians are 100 members and their chance of getting a chest disorder is 20%. Next one, non-smokers and vegetarians, they are very good persons and they are 140 and for them also there is a chance of getting a chest disorder but it's a very small in person, that is 10%. So, first one person is selected. One person is selected from this 400 and he has a chest disorder, obviously. Why? Because all have a chest disorder. And what is the probability that the selected person is from smoker and non-vegetarian? Smoker and non-vegetarian. Okay now, right. So, first let A1 be the event of selecting smoker and non-vegetarian, smoker plus non-vegetarian. Okay. Now, what is the probability of A1? What is the probability of A1? Total how many members are there? 400 members. Out of that 400, 160 members are smokers and non-vegetarians. That is equal to probability of selecting a person who is a smoker and a non-vegetarian is 160 by 400. Okay now. So, this is given by 0.4. Similarly, A2 be the event of selection of a person, a smoker and a vegetarian. So, this is a probability of A2. This is equal to 100. There are 100 by 400. This is equal to 1 by 4. This is equal to 0.25. Again, third one, probability of A3. Let A3 be the event of selecting a person who is non-smoker and vegetarian. It is given by that total, this is 140 by 400. This is given by the value 140 by 400. This is 0.35. Okay na? 0.35. Now, coming to here, this is a probability of selection of a person. Coming to chest disorder. So, let E be the event of getting. Let E be the event of getting chest disorder. Let E be the event of getting chest disorder. That is what probability of, it is a conditional probability. That is what E given A1. That means first happening of A1 after the happening of A. Ante what is the meaning of, if you are selected from this category, that is smokers and non-vegetarian, what is the chances of getting? That is 35%. 35%. That means what? 35 by 100. 35 by 100 means 0.35. Okay. Similarly, probability of E given A2 is 20%. 20% means 20 by 100. This is equal to 20% means 20 by 100 means 0.2. Probability of E given A3 is equal to 10%. 10% means 10 by 100. This is equal to 0.1. So, understand this. First you are selecting a person. From this is an event of getting a chest disorder. He is given 35%. That means 0.35. This is a 0.2. This is 0.1. Now, what you have to find out? We have to find out the probability of the selected person. The probability of the selected person is from smoker and non-vegetarian. That means we have to find out probability of A1 given E. That you have to find out. Probability of A1 given E. So, therefore, by Bayes theorem, just now we have seen. So, what is the probability of A1 given E? Probability of A1 given E. What is the probability of A1 given E? So, probability of E given A1 into probability of A1 divided by, again this we will write down, probability of E given A1 into probability of A2 plus probability of E given A2 into probability of A2 plus probability of E given A3 into probability of A3. Only here 3 events are there. So, according to this Bayes theorem. So, all values are known to us. So, let us substitute these values here. So, shall I, so I will substitute all these values. Shall I rub this? Okay. So, I am rubbing this for your clarity. Right. Okay. So, let us coming to our problem. So, this is equal to probability of E given A1 is equal to how much? 0.35 into probability of A1 is equal to how much? 0.4 divided by 0.35 into 0.4 plus 0.2 into probability of A2 is equal to how much? 0.25 plus probability of E given A3 is 0.1 into probability of A3 is 0.35. Okay. So, if you calculate all these values, so you will get the answer 28 by 45. 28 by 45. So, it is a very, very easy problem. It is a direct problem. So, this problem will be done using Bayes theorem only. Understand? So, I hope that you understand this solution very clearly. So, let us go for next problem. So, dear students, welcome to our third problem. First read the third problem. a fair coin is tossed a fixed number of times. If the probability of getting 7 heads is equal to the probability of getting 9 heads, then the probability of getting 2 heads is, okay, once again see the problem. A fair coin is tossed a fixed number of times. We don't know the how many times it tossed, but we don't know, but it is given that the probability of getting 7 heads is equal to the probability of getting 9 heads. That is given. Then the probability of getting 2 heads is, okay. Now to do this problem we should know one basic formula from the chapter probability. What is that basic idea is, let x be the random variable. Let x be the random variable representing the probability of success, representing the number of success, representing the number of success. Then it is given by probability of x is equal to r is equal to NCR p to the power of r into q to the power of n minus r. Here what is r means? Probability of success. Probability of r successes or number of success. So here probability, what is p? It is a probability of success. Q is probability of failure. For any random experiment you will have a probability of success and probability of failure. So let x be the random variable representing the number of success. Okay, now then probability of getting r success is equal to NCR into p power r times q to the power of r, where r is equal to 0, 1, 2, 3, so on n. Number of success means definitely it should be less than total number of trials. Okay, now so if you know this formula, so we can easily solve this problem. So probability of x is equal to r is equal to NCR into p to the power of r into q to the power of r. Okay, so let us move to the solution of the main problem. So dear students, coming to this problem, when a fair coin is tossed a fixed number of times, when a coin is tossed, what is the probability of getting head? Probability of getting head is, we know that it is 1 by 2. Probability of getting tail is also 1 by 2. That means both have the same chances of happening. So generally we represent this as a p and we call it as a q. Okay. So here let n be the number of tosses. Let n be the number of tosses. Here what is given? Probability of getting 7 heads. Probability of getting 7 heads is equal to probability of getting 9 heads. So this is given by the formula NCR. N we don't know. NC 7 successes. That is NC 7 into P power R. P means how much? P power R means what? P means 1 by 2. P means 1 by 2 whole power 7 into 1 by 2 whole power n minus 7 is equal to, here n we don't know, number of trials we know, we don't know that how many successes are there? 9 successes are there. This is 9 into 1 by 2 whole power 9 into 1 by 2 whole power n minus 9. Now if you solve this, if you observe this, 1 by 2 whole power 7 into 1 by 2 whole power n minus 7, that means a power m into a power n, a power m plus n, that is 7 plus n minus 7. 7 minus 7 will get cancelled, that is 1 by 2 whole power n. This is also 1 by 2 whole power n. These two will get cancelled. These two will get cancelled. So what you will get here? So NC7 is equal to NC9. This implies n is equal to 7 plus 9, that is equal to 16. So therefore, how many is tossed, how many number of times? If it is if you toss 16 times, then the probability of getting 7 heads will be equal to the probability of getting 9 heads. Now he is asking the probability of getting 2 heads. So probability of getting 2 heads is given by, here n value is equal to how much is 16, that is 16C2 into 1 by 2 whole to the power of, this is a 2 into 1 by 2 whole power 16 minus 2. Okay now, so if you calculate all these value, that is a 1 by 2 whole to the power of 16 will come, and the 16C2 value also if you calculate, so this is 16C2 value is a 16 into 15 by 1 into 2. This is a power m into a power m plus n, 2 minus 2 will cancel. This is a 1 by 2 to the power of 16. 1 by 2 to the power of 16, and it is 2 to the power of 17. This is a 2 to the power of 4, 2 to the power of 4, and it will cancel. In the denominator we will get 2 to the power of 13. So altogether that this is 15 by 2 to the power of 13. Therefore your answer is C is the correct answer. Okay, so very easy problem. So let n be the number of tosses. So number of n times tosses, the probability of getting 7 heads is equal to probability of getting 9 heads. So if the number of tosses are 16, that means if you toss 16 times, then only the probability of getting 7 heads will be equal to the probability of getting 9 heads. And he is asked to find out the probability of getting 2 heads, that is given by 15 by 2 power 13. So the problem solution is, answer is C. So dear students, I hope that you are all following all these classes. So previously also I explained the problems from permutations and combinations. So if any students wants the videos of that permutations and combinations, and in our link I have given the link for those permutations and combinations also. The very important problems they are. So if you want the solutions for those problems also, so please go through the link below. Okay now, so that's all about today's class. Let us see the remaining problems from probability in next class. Thank you.